We just saw how the fifth identity the fifth identity is helpful for us in expanding the given terms. Now let's see how to factorize using the fifth identity when a question is given to us. Suppose a question is given of this sort: 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16 is xz. Before solving or getting into this problem, please find or please solve a question of the type that we just did above, that is expansion of a given set of numbers of the form x plus y plus z or x minus y minus or x or any number having a negative symbol in between this one. Then it will be more clear, so I would recommend to watch the video before getting into this section. Anyway, we will try to solve this one. First of all, we should analyze the question given to us. It is 4x square plus 9y square plus 16z square. All these numbers can be written as something whole square, right? If you get that as the something whole square, then half of our job is already done. Then all we need to make is to make sure you are not getting wrong in this or with this negative symbol. If that is done, everything is okay. So first of all, we can make this as, so here I am going to write the answer. 4x square is nothing but 2x the whole square. I hope that's fine. But still we don't know whether it is minus 2x or plus 2x. So whatever it will be, we don't have a problem here, because any number squared will become, or any, whether it be negative or non-negative, when it gets squared it becomes positive. So we don't know whether it was minus 2x. Let's write 2x itself plus. So 2x is our first term. This is our 2x, the first term. Now 9y can be written as something whole square. Who is that? 3y the whole square. So our second term is either 3y or minus 3y. I hope why I said this particular statement. Then our next term is 4z the whole square. So our third term is 4z or minus 4z. Now we will so already we have got the three numbers, but the symbol, whether it is plus or minus, is still left as a doubt. It will be clarified once we complete this one. Now the fourth term is written of the form 2 times first number into second number. That is 2 times, who is the first number? 2x into second number is 3y. If you are getting it as the same, then no need of changing. Let's check. 2 into 2, it's 4. 4 times 3 is 12. So number is okay. Then x into y. And is both of them positive? Yes, both of them are positive. Now let's move on to the next part. It should be of the form 2 into second number into third number. That is 2 into, who is the second number? It is 3y into, who is the third number? 4z. Now let's check whether it is satisfying. 2 times 3 is 6. 6 times 4 is 24. So 24 is done. Y into z is yz. So it's okay. Do you think it's okay? No, because the symbol over here is plus and the symbol over here is minus. So either the second term or third term is negative. We don't know which term is negative. It can be 3y who is negative or 4z who is negative. For that, we will keep this both of them as a suspicious element. Then coming to the next term, who is it? 16z, xz. That is also of the form 2 into first number into last number. 2 into first number. Who is the first number? It is 2x into, who is the last number? It is 4z. Now 2 into 2, 4. 4 into 4 is 16. So it's done. X into z. It's also condition satisfied. But here also a negative symbol is appearing. We have already found that first number is positive. First number is positive. So the only chance for becoming this one negative is that the last number or the term 4z is negative. So we have got the thief. 4z is the negative term. Just apply this 4z negative over here also. So I hope you understood this one. Earlier we have seen that both first term and second term are positive. Then only you will be getting this whole term as positive, that is plus 12xy. So this is the concept. Now we can rearrange this in a different way. Which is the negative term that we have? It is the third term, 4z, who is negative. Then we can write, or instead of x square plus y square plus z square, this whole thing, we can write this one, right? X plus y plus z the whole square, just as we did in the first and the identities up to 4. We can factorize if this whole thing is given. Then how will it be? First term plus second term plus third term, the whole square. So who is our first term? 2x plus second term is 3y. And who is the third term? Is there any difference for the third term? Yes, there is. It is minus 4z the whole square. So this is the factorization of this whole thing. If you are doing it for the first time, you may feel a small doubt, but there are some more example questions in your textbook. Try to solve them, then it will be very comfortable for you. Now it's said to factorize, so we should make it as product of two different terms. So it will be minus 4z times 2x plus 3y minus 4z. That's it. Sixth identity says x plus y the whole cube, that is sum of two numbers to the power 3 will be x cube, first number cube, plus 3 times first number square times second number, plus 3 times first number into second number square plus the second number cube. In the textbook it's written in a different way, but more or less they are the same. So I would recommend to follow this method or this way, because the next identity also follows the same pattern, just with a difference of a negative symbol. That is x minus y whole cube can be written as x cube minus 3x square y plus 3xy square minus y cube. Let's try to solve some problems based on this one. This is one of the exercise question that is in your textbook. First one, find the value of 102 the whole cube. As we learn how to find the square of number by splitting into two terms, we can do the very same process over here also. So I am going to write 102 whole cube as 100 plus 2 the whole cube. Now we have learned an identity to find the sum of the two numbers to the power 3. So we can write 100 plus 2 whole cube as first number cube, that is 100 cube, plus 3 times first number square, who is the first number? 100 square, times the second number, who is second number? 2, plus 3 times the first number, 3 times, who is the first number? 100, into second number square, that is 2 square, plus the last number cube, who is the last number? 2. So if you add all of this, then you will get the value of 102 to the power 3. Let's see. 100 cube means 100 into 100 into 100. So how many zeros in total? 6 zeros. 1, 2, 3, 4, 5, 6. I hope you understood that one. 100 into 100. Then 4 zeros will be there. Then again 100 will give 6 zeros. Plus 3 times 100 square is 10,000. So we can write 10,000 into 2 plus 3 times 100 into 2 square. 3 times 100 is 300. So let's write that way only. 3 into 100 into 4, because 2 square is 4. Then plus an 8. Now all you need to do is to add the 3 terms together. I will do it here. 1. Then how many zeros? 6 zeros. 1, 2, 3, 4, 5, 6, plus 10,000 into 2 into 3. 2 into 3 is 6. 6 into 10,000 is 6,000. So there will be 4 zeros and a 6. Then who else do we need to add? 3 into 4 is 12. 12 into 100 is 1200. So right, 1200 plus and 8 is also there. So we just add it together. There is 8, 0, 2, 1, 6, 0, 1. So let's check. 106, 1208. Yes, that is the correct answer. Even if you multiply 102 times 102 times 102, this is effectively 102 whole cube. If you find this one, you will get no different answer. That is 1061208. So this is the application of this x plus y whole cube. There is another one, another question it's given there. Find x minus 2 by 3y the whole cube. So it's of the form x minus y the whole cube. Now let's try to solve this one. Clearly this is of the form a minus b whole cube. X minus y the whole cube. So we can write first number cube. Who is the first number? First number is x. So we can write x cube minus 3 into x square. X square means the first number square. First number here is x square itself. Then into second number. Second number is 2 by 3 y. Then who is the next term? Plus 3 times first number into second number square. First number is x into second number is actually 2 by 3 y. Its square needs to be taken. So 2 by 3 square is 4 by 9. Also y. Y square is y square. Then last term is y cube. Y means second number. Who is the second number? 2 by 3 y the whole cube. So that will be it. Just solve it. X cube means x cube, no different. Minus, we can cancel this 3 in the numerator and denominator. We can write 2 is there in the numerator. Then 2x square y plus, we can cancel this 3 and 9 by 3 itself. So who will be in the numerator? There will be a 4 and the denominator there will be a 3. Then there will be x y square because this is x and this is y minus. Now can we do anything further here? 2 cube is 8 divided by 3 cube is 27 and there is a y, so y cube. So the answer will be x cube minus 2x square y plus 4xy square by 3 minus 8 by 27 by 2. Yes, that's the correct answer. So this is the application of 6th and 7th identity. Now this is the expansion. Now let's go for the factorization of both of them. Now let's see a couple of problems based on the identities that we have learned now. First question is asked to factorize the given polynomial 8a cube plus b cube plus 12a square b plus 6ab square. According to the identity that we have learned, we have arranged the terms containing the power 3 in the left and right extreme. So given question can be written of the same form. So I am going to answer the first question here. 8a cube plus, I am going to rewrite it in a way that the term containing cube will be in the either extreme. So I am putting 8a cube here and b cube will be taken to the right extreme. So in between, who is the 12a square b plus 6ab square, and then comes our b cube. Now this can be done in single step, because if you find this has something whole cube and this has also something whole cube, then the whole answer is done, provided there is no negative symbol. If there is negative symbol, then only the second thought should be there to check whether it is x plus y or x minus y. If there is no, then we can immediately write in the next step itself. So this can be written as 2a the whole cube and b can be written as b the whole cube or simply b cube. Now for the sake of the question, let's completely make it into the form of 3x square y, that is 3 into first number square into second number. Now the first number that we assume is 2a and the second number is b. So according to the expansion, it should be of the form 3 into first number into second number. Just see whether it is satisfying after putting that same. First number is 2a and the second number is b. Also the second number, the first number should be squared. Let's see whether we are getting it. 3 into, what is 2 square? Is 4 into a square b. So it is like 3 into 4 into ab, that is 12ab. Are we getting the same? So 12a square b. Are we getting the same? 12a square b. So it's done. So this one is okay. Then let's see, 2 into first term 2a into second term square, that is b square. If you solve this one, we should get 6ab square. Let's see whether it's getting 2 into 3 is 6. 6 into a into b square, 6ab square. So it's satisfied. So we can write this as 2a plus b. How? First number plus second number whole cube. So this is how to factorize this one. Now let's solve the second question. Factorize 64a cube minus 27b cube minus 144a square b plus 108ab square. We use the same concept. First we'll write 64a cube over here. Then the next term should be 144a square b plus 108ab square. Then the last term as 27b cube. If you still find or if you are able to find this as something whole cube, then it's more than enough. So we know 64 is 4 cube. Then we can write as 4a cube, and the last term is nothing but 3b the whole cube. So effectively we already can write the answer as 4a minus 3b the whole cube. This will be our answer. But we need to make it into the standard form. So it will be 3 times first number square. Who is the first number? 4a. That is 4a the whole square into second number, that is 3b, plus 3 into first number is 4a into second number is 3b the whole square. So it will be of this form, minus 3b the whole cube. So effectively we can factorize this one as 4a minus 3b the whole cube, or it's just like 4a minus 3b into 4a minus 3b into 4a minus 3b. So that is the factorization of this particular identity. Now let's move on to the last identity of our chapter, identity number 8. This identity is a bit different from all the 7 identities that we have learned so far. It's just a simple application, or we can just simply apply this identity whenever you find any polynomial of this particular format. That is, if you are given something cube plus next number cube plus third number cube minus 3 times the product of the 3 initial numbers or initial terms, then we can write the given polynomial as sum of the terms. That is, it should be something cube, something whole cube. That particular number or that particular 3 numbers should be added together, and their product being multiplied with the sum being multiplied with x square plus y square plus z square minus xy minus yz minus xz. So let's see how to solve this particular question using this identity. A question is given: 8x cube plus y cube plus 27z cube minus 18xyz. We need to factorize this into 2 different terms. If that is needed, we can use this identity, because if you use this identity, then we can make it as product of 2 different numbers, right? So let's try. First of all, it should be something cube plus second number cube plus third number cube. Is it of this format? No. But we can make, if we make a slight rearrangement to all the terms. So let's try. First number 8x cube. How will you write 8x cube as something whole cube? We have been doing it since the beginning of this particular chapter. So 8x cube is nothing but 2x the whole cube. Now y cube is already there, so we don't need to make any rearrangement. But 27 is the cube of 3. So it's effectively the cube of 3z. Minus, and how should the next how should this term be? It should be 3 into first term into second term into third term. Let's try. 3 into first term. Who is the first term? 2x into who is second term? Y into the third term is 3z. Now we should verify that the product of this should be nothing but 18xyz. Let's try. 3 into 2 is 6. 6 into 3 is 18xyz. So our condition is satisfied. Now we are eligible to use this particular identity. Why? This is clearly of the form x cube plus y cube plus z cube minus 3 times the product of the x, y and z. So we can use, and what can we equate this into? Sum of the 3 terms. So first of all, let's try. then we can write it as sum of the three terms. For the terms 2x plus y plus 3z into. Now comes the important part, x square. First number square plus second number square plus third number square. Who is the first number? First number is 2x the whole square plus, because we are asked to find the square, plus second number square. Second number is y itself, y square, plus third number is 3z, that also square. Then minus first number into second number. Who is the first number? 2x into, so I put it inside a bracket, 2x into y minus y into z, that is second number into third number. Second number is y into third number is 3z minus, who is the last term? X into z, first term into last term. Who is the first term? 2x into last term is 3z. Now we will just write down in a simple way. We don't need to make any change to the first term. Let it be as it is, 2x plus y plus 3z times. Now for this 2x whole square is nothing but 4x square plus y square is y square itself plus 3z the whole square is 9z square, then minus 2 into xy, that's 2xy, minus y into 3z is 3yz, minus 2 into x into 3 into z, that is 6xz. So this will be our final answer. So we have got this particular question. Who was it? 8x cube plus y cube plus 27z cube minus 18xyz as the product of two different terms. Here is the first term and here is the second term. All we did is to apply this identity number 8. First of all, we made this question into this particular format, and if any polynomial is in this format, we can apply the identity number 8. We just use the same. We just substituted all the values x, y and z. X means first term, y means second term, z means third term, and we got the final answer as the product of two different polynomials. I hope you understood this, and that's the end of this chapter. There are some more exercise questions. I have just took the important questions that I felt that may feel to be difficult for you. So all the remaining questions are left for you as the classwork or homework. I hope everyone would do the same. And thank you for listening to the classes.